and welcome everyone. Today we'll be going through another new counting technique which is called permutations. Permutations essentially are a way to figure out how many different arrangements of a certain collection of entities can be done. So let's get started with a very simple problem. Let's say I ask you to tell me how many different ways can you arrange the numbers 0 and 1. This seems like a very simple problem and can be easily solved by enumeration, wherein you can say that we can order 0, 1, and 1 followed by 0, and so there are two different ways of arranging um, the numbers 0 and 1. But let's say I asked you how many different ways can you arrange all the letters in the English alphabet, going from A to B to C up to Z. Hmm. This might be a slightly complicated problem because you might have to write down all the possible permutations or all the possible ways of arranging the letters from A to Z, which may take you quite a long amount of time, right? So we learn some interesting techniques to easily solve that problem using using simple mathematical tools. A way to understand this problem is that we can so let's say imagine that you have two different buckets. So let's say this is bucket 1 and this is bucket 2, and each arrangement essentially consists of throwing one of these letters into either bucket 1 or bucket 2. So how many ways can you throw a letter into bucket 1? Two ways, right? Because you can either throw 0 or 1 into bucket 1. And how many ways are there to throw any letter into bucket 2 given you've already thrown one letter into bucket 1? There is only one way, because you would either have thrown 0 in bucket 1, so you're only left with 1, or you would have thrown 1, you would be left with 0. So this turns out to be 2, which is the right answer. But let's now extend this and think about 26 such buckets. So this might be slightly harder and may take some amount of time, but let's think and say how many ways are there to throw a letter in the first bucket? 26. Putting into the 26 letters in the alphabet. How many ways are there? If you've thrown a letter in bucket 1, how many ways are there for throwing a letter in bucket 2? 25, right? Because you've already thrown one of the letters in bucket 1. Let me just write these bucket numbers as well. Bucket 2, bucket 3, bucket 26. How many ways are there of if you've thrown two letters in bucket 1 and 2? How many ways are there? 24. And extending this, how many ways would there be of throwing a letter in bucket 26? There would be just one way, given the fact that you've already thrown all the rest 25 elements in different buckets. So this turns out to be a very simple way of deducing, which is essentially how many ways can you permute the alphabets into these 26 buckets. And that turns out to be n, which is the first bucket, into n minus 1. And this is applying the rule that we learned, that if you have n ways of doing a task and n minus 1 ways of doing the next task, the total number of tasks would basically get multiplied up to n up to 1. So we write this as total number of ways is equal to this. This is in mathematics is also written as n permute or n permutation, denoted by the symbol of permutation, and it turns out to be n. Permutation, it's also called factorial. So we call this as factorial. Some other ways of asking the same question is given given 5 books that Harry has, how many ways can he arrange those 5 books on a table? So this is Harry's table. He has to arrange these books, but how many ways can he do that? So the answer to this would again be n, which is equal to 5 factorial. Factorial, which is 5 factorial. And this turns out to be 5 into 4 into 3 into 2 into 1 turns out to be 120. So permutation is a very strong concept in mathematics where you get to choose or you get to figure out the total number of ways in which a certain collection of objects can be arranged. Hope you understood this concept. We'll give more examples in the following tutorial and hope this will help you out in understanding and gaining deeper insights about permutation as a mathematical tool. Thank you.